Again, what we're talking about is limit from the left is the negative superscript, limit from the right a plus superscript, and then both sides is going to be no superscript at all. So when we're finding our limit, we're asking ourselves as x approaches c, what do those y values approach? All right, so if we look at this example here, we have another function, new graph, and we're looking at the limit as x goes to 0 first from the left-hand side. So because we're looking at it from the left, we are going to cover everything to the right of 0 on the graph. And we ask ourselves, as x gets really close to 0, so again, we don't care about the behavior over here, we care about as we go into 0, as x goes to 0, what are these function values approaching? And if we follow the graph up towards this edge of the piece of paper, that's going to tell us what the function values are approaching. So in this case, we see that our function values are approaching 4. So we would say that our left-hand limit is equal to 4. All right, now if we look at it from the right-hand side, what we would do is we would cover the left-hand side, so the other side of the graph, starting at x is equal to 0. Now, if I look at as x goes to 0, I see that my function values are approaching, they're coming down towards this number here. And so that is going to be y is equal to -1. Now again, because of the fact that this one-sided limit is not equal to the other one-sided limit, that allows us to say that the two-sided limit will be a does not exist because those two are not equal. So we would say that the limit from both sides, no superscript, would be equal to 0. Okay? Now, we of course need to look at an example where the two-sided limit does exist. So let's look at this graph over here. So this graph, we have no subscript, so we have to consider both sides. So we look at the limit from the left first. So we'll look at covering up the right-hand side of the graph. And as x goes to 0, we see that all of our little function values are coming in towards this point right here. And that point, of course, is the origin. So they're coming in towards 0, 0. Remember that the limit is always equal to a y value. So we are interested in the y value of 0, which is why we will say the limit from the left is equal to 0. Now, I also have to look at the limit from the right-hand side. So if I cover up the left to look at the right-hand side, I see that as x approaches 0, all of my little function values are coming in towards that same point. Again, there's an open circle there, but nobody cares about the open circle. It's all about what that arrow is pointing towards. So if I draw the function and I look as I come in, I'm coming in towards that same y is equal to 0. So that tells us the limit from the right-hand side would also be equal to 0. Now, because both of these one-sided limits are equal to 0, that allows us to say that because these one-sided limits are equal, the two-sided limit will exist, and it's going to equal exactly that number that those one-sided limits are equal to. So this limit of f would be equal to 0. All right, let's look at one more here. So again, we're looking at a new graph. We have the limit as x goes to 1. So now we are approaching x is equal to 1 on the x-axis, and we want to see what our y values are approaching. So in this case, we cover up first the right-hand side to look at the left-hand limit. And when I do that, as x goes in towards 1, we see that all of these little y values are marching up towards that edge of the sheet of paper, and that is pointing towards a y value of 1. So our limit from the left would be equal to 1. Now, if I cover up the other side, we see that the limit from the right-hand side now, again, we look at as x goes towards 1, all of these little function values are approaching this point. So again, we draw the arrow up to that piece of paper, and they're approaching at 1. So we would say our limit is equal to 1 from the right-hand side. Now, if we're asked for our two-sided limit, what we do is we use this information about the one-sided limits. So because these are both equal to 1, that allows us to say that the two-sided limit does exist and is equal to 1.